Hi there, welcome to edupediaworld.com. You're watching the videos on statistics questions. So in this video we'll discuss again more questions related to histogram, bar graph and polygons. So again these questions are very important from the exam point of view. So you have to watch this part of the video again very carefully, right? So let's get started with the first question, which is question number 1. Now the question says that the length of 40 leaves of a plant are measured correctly to 1 millimeter. And the data obtained is represented in the following table, right? Now we need to, first part is we need to draw a histogram to represent the given data, right? And the hint is given is first make the class interval continuous. If you can see properly, this is 126 and this is 127. So the data is not continuous. So we have to make a data continuous. So we'll learn how we can make the data continuous. And the second part is there any other suitable graphical representation of the same data? Can we use this data to draw any other graphical representation? And third part is it correct to conclude that the maximum number of leaves are 143 meter long, and why? So we'll discuss each and every question very carefully, right? So let's get started. Now first of all we need to make the data continuous. Now let's say if we have 118 to 126 class, so this means this value is included, however this value should not be included. This is the rule for the class, means the upper limit is not included, the lower limit is included. Now let's suppose if we want to consider both the limits, then what we can do is we can expand this values. Let's say if I write 117.5 and 126.5, right? If I expand or if I increase the width of the class like this, so if you consider this class now, then 118 will be included in this class and 126 is also included in the class. So this make the data continuous, right? So rule is to make the data continuous. The first rule is you need to subtract 0.5 from lower limit, and second is then further we need to add 0.5 to upper limit, right? So these are the rules. So now let's draw the data or draw the frequency distribution, group frequency distribution data again correctly for the continuous, to make it continuous. So let's say we have a table like this, right? Now let's say this is a table. So this is length in millimeter and this is number of leaves. Now so this will come out to be 117.5 to 126.5. so number of leaves are 3. Then this will come out to be 126.5 to 135.5. so this will come out to be 5. Then this will come out to be 135.5 to 144.5. so this will come out to be 9. Then this will come out to be 144.5 to 153.5. so this will come out to be 12. Then it will come out to be 153.5 to 162.5. so this will be 5. Then this will be 162.5 to 171.5. so this will be 4. This will be 171.5 to 180.5. so this will be 2 again. So this is the correct data, or we can say continuous data, group frequency distribution table. Now we need to draw the histogram for this. So let's do it then. Let's say we draw like this, right? Now first of all we need to choose a scale. So let's draw the scale. We can write for the x-axis, right? There are leaves, highest is 12 and the lowest is 2. So we can say that 1 centimeter represents 2 leaves, right? And the scale for y-axis can be written as, we can say that, so this is the length in millimeter, so we can say that 1 centimeter equals to 5 millimeter, or we can say that if you see the we can say width of a class, it is 126.5 minus 117.5, so which is 0 point, so this will be 16, take away 7, so which is 9, right? So it is 9, so width is 9, you can see properly. So we can say that scale for y-axis is 1 centimeter equals to 9 millimeter, right? So this is the scale now. Now what we need to do is we need to write length over here, or we can say we need to write number of leaves on y-axis, right? And on x-axis we need to write length, right? So if this is 0, then it will start from 117.5. So we can start it from 117. So this is 117. Then we can have a unit of 9. So this is 117. So this will be 126. So this will be 135. So this will be 144. Right? We can have a till 180 or 80 above 80, right? So that we can include the data. So this will be 153, then this will be 162, then it will be 171, so this will be 180, then we can have further data, so this will be 189. So this is the data now. So for y-axis we need to write the data. So this is 0, 2, 4, 6, 8, right? So this can be 10, 12, 14 and 16, right? Now if you can see properly, if you remember, when we draw histogram, we need to draw the kink if the class is not starting from 0, right? So here we need to draw the kink like this, or a break. So it is a very useful point, you have to remember this always, right? Now let's draw the histogram for this. So the first class is 117.5 to 126.5, so it will start somewhere from here and it will end somewhere over here, right? And the frequency is 3, so it will come over here. So this will be the data, right? Then the next class is 126.5 to 135.5, so this will be the point and this will be the value. So this will come out to be 5. So this is the point, right? Then it is 135.5 to 144.5, so this is 9. Right? Then comes 144.5 to 153.5, 12. So this is the data. 153.5 to 162.5 comes 5. Then this is the data. Then comes 162.5 to 171.5, so this is the 4. So this will come the data. Then comes 171.5 to 180.5, the value is 2. So this will be the histogram. So this is the drawn histogram for the corresponding data, right? Now, is there any other suitable graphical representation for the same data? Yes, there is. We can draw also a polygon, isn't it? We can draw polygon, right? By taking the midpoints like this. If we take midpoints of each graph, right? And what we can do is we can draw the midpoints by the dotted lines like this. So it will be a polygon, and when we can have one succeeding and preceding class with 0 frequency, right? Then we can close the polygon. So this is another way of representing the data, right? Now, is it correct way? Third part is it correct way to conclude that the maximum number of leaves are for 153 meter long and Y? No, it's not, because the data is group data. It is, so we can write for this, it is not correct way to conclude. Why? Since the data is group data, right? So we need to write the class of maximum frequency. So for the group data, we always write the group class with the maximum frequency, right? So this is how you have to represent the data, and this is how you have to do these type of questions. So let's move on to the next question, which is question number 2. Now the question says that the following table gives the lifetimes of 400 neon lamps. So these are 400 neon lamps. So you need to represent the given information with the help of histogram. And the second part is how many lamps have a lifetime of more than 700 hours. So it's very easy questions. So let's do this question very quickly then, right? So if we need to draw the histogram for this, so let's do it then. So let's say we draw like this, right? Now, so over here it will come number of lamps, and over here it will come, you can say, lifetime in hours, right? Now, so let's say this is 0. Now what we need to do is we need to represent the data. First of all, we need to write the scale. Now the scale for x-axis, it will be, we can say that the class width is 100, and first of all we need to check the class width. So each class width is 100. So this means this have a equal class width, right? Now we need not to have a proportionate data then, right? You remember we have discussed this question and these type of question in the previous videos also. Now for the x-axis, we can say that 1 centimeter equals to 100 hours of lifetime, and for y-axis we can write 1 centimeter represents 5 lamps, right? So then draw it. So this will be, now maximum number of lamps is 86, right? So you have to consider this part also. So this will be 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, then this is 90, right? Then we need to write in hours. So this is 100, 200, 300, 400, 500, 600, 700, 800, 900 and 1000. So these are the data then. Now let's draw the histogram for this. Now, so for the first, it starts from 300 to 400. So this means we need to draw the kink. So let's draw the kink over here. So this is a 300 to 400 and the number of lamps are 14. So this will come over here. So this will be the data, right? Then 400 to 500, it is 56. So this will come somewhere over here. So this means we need to draw the data over here. Then 500 to 600, it is 60. So this means this is the data point. Right? Then we have 600 to 700, which is 86. So this will come somewhere over here. Right? So this will be the data point. Right? Now for 700 to 800, it is 74. So this will be the data point. Right? Then from 800 to 900, it is 62. So this will be the data point. Then for 900 to 1000, it is 48. So this will be the data point. Right? Now, so this is the representation of a data with the help of histogram. Now, second part is how many lamps have a lifetime of more than 700, means it should be more than 700. So this means we need to calculate the lamps number of lengths from this data point for these number of group classes, because this class starts from 700 and ends 1000. So this means the question asks us how many lamps have a life of more than 700. So this means we need to add all these frequencies. So this will be 74, 62 and 48. So this will be 8 plus 2 is 10, 10 plus 4 is 14. This will be 10, 11, 18. So we can write for the second part, 184 lamps have a lifetime of more than 700 hours. So this is how we can do these type of question. Now let's discuss the next question, which is question number 3. Now the question says that the following table gives the distribution of students of two sections according to the marks obtained by them. You need to represent the marks of a student of both the sections on the graph, same graph, by two frequency polygons. So we need to draw two frequency polygons, and from the two frequency polygons we need to compare the performance of the two sections. Right? So first of all, for frequency polygons we need to check the class width. So it's all same. Right? Then we need to have a midpoint. Then before that we need to have one succeeding class and one preceding class with frequency 0, so that we can close the polygon. Right? So let's do it. So let's have one succeeding class from -10 to 0 with frequency 0, and one is from 50 to 60 with frequency 0. So this is the two class with frequency 0. Now let's have a midpoint. So for this, the midpoint we can write over here midpoints. Right? Now, so for the first, or we can write for this class, succeeding class or preceding class, the midpoint is -5 with, right, frequency is 0. We need not to write the frequency. Then for this class the midpoint is 0 plus 10 upon 2, so which is 5. So we can write 5. Then for the next class it is 10 plus 20 upon 2, so which is 30 upon 2, which is 15. Then the next is 20 plus 30 upon 2, so which is 50 upon 2, which is 25. Right? Then we have 30 plus 40 upon 2, so which is 35. Right? Then we have 40 plus 50, which is 90 upon 2, which is 45. Right? So these are the midpoints. Now we need to draw the frequency polygon. Right? Now, so over here you can see the frequency, the maximum frequency is 17 for this data and the maximum frequency is 19 for this data. So this means we can choose the scale for y-axis. We can, let's say we can have 1 centimeter equals to 2, right? 2 students. Then for the x-axis, we can have the class width is 10, so we can have 1 centimeter equals to 10 marks, right? So over here now let's draw it. So this is 0, this is 2, this is 4, this is 6, this is 8, 10, 12, 14, 16, 18 and 20. So for this let's draw it. So this is 0, this is 10, 20, 30, 40 and 50. So these are marks and these are students, right? Now we need to draw the 2 frequency polygons on the same graph. So we can say I'll use the 2 different colors for this so that you can see it very easily. For section A, I'll use red color, and for section B, I'll use black, so that you can differentiate very clearly, right? Now for the first, it is minus, it is for first midpoint, it is 5 with the frequency 3, so this means it will come over here, somewhere over here, so this is the point, right? Then with 5 the frequency is 9, for the 15 the frequency is 9, so this will come somewhere over here. Then with the frequency 25 it is 17, so this will come somewhere over here. Then with frequency 30 to 40, which is 35, it is 12. Then the frequency 45, with data point 45, the frequency is 9. So this is the point, right? So then we need to draw it like this, right? Now we need to close the data, we need to close the polygon, so we use succeeding and preceding class. So this is minus 10 to 0 with frequency 0, so it is minus 5, the point is minus 5, so this will come over here, somewhere over here. So we draw like this, and next point is 50 to 60, it will be 55, frequency 0, so this will be the point. So we close the polygon like this. So this is a polygon for the section A. Now we need to draw the polygon for the section B. Now for polygons for the section B, for 0 to 5, its frequency is 5, so this will be the point, right? For the next 15 midpoint, the frequency is 19, so again so this will be the point, right? So for the frequency 25, midpoint 25, the frequency is 15, so this will be the point, right? So for the midpoint 35, the frequency is 10, so this is the point. So for the midpoint 55, or for the midpoint 45, the frequency is 1, so this will be the point and the frequency. Now we use, first of all, we connect the data with dotted lines, right? Now you use the preceding and succeeding class, so this will be the point and this will be the point. So we close the polygon like this. So this is the these are the 2 polygons we have. Now from the 2 polygons, we need to compare the performance of 2 sections. If you can see properly, the performance of section B is, let's say, is much, you can say, on an average. However, section of B performance, it's much we can say, or we can say better on average to performance of section A. Why? Let's first use the data. Now if you can see, we have high frequency of data from 10 to 40, right? So this means on an average the students of the class perform very well between this data. However, if you see for section A, only few represents 17 to 12 from the 20 to 40, right? So this means on an average section B class is good as compared to section A. However, the highest mark scorer, highest marks scored are more in section A than B, right? So this is the data. We can conclude the information from the data. If you see the polygon, if you see this polygon for the section B, it's more inclined toward the positive side, right, than section B. So this means on an average section B is performing well than section A. So this is how we can conclude from the polygon which section is better than the section A. And we can have n number of information from the polygons. Let's say we can have the area of the polygon, then we can compare a lot of things which we'll learn more about in higher classes, right? So this is how we can use the polygons, we can draw the polygons, and we can have useful information from the polygons and the data. So in the end, I can say that thank you for watching the video on edupediaworld.com. Keep watching further videos. Have a nice day ahead.